Hi 20-1s, this is lesson 8.2, solving systems of equations algebraically. So it's important to be able to do these questions both algebraically and graphically because it gives you a checking method. So if you do this question algebraically, you could check graphically or vice versa. So you can apply this method of substitution and elimination that you should have learned in 10C. So I'm going to review those concepts with you as we go through this lesson. So what you want to do is just make sure that you're confident in doing both methods because it does make it easier to have both in your pocket. So in this first one, they're giving us a linear equation and they're giving us a quadratic equation. So what we want to do is we want to, in this case, we could do, in this case, substitution. So it makes more sense when they are both two different equations, one being linear, one being quadratic, to do substitution. So we're going to solve for the variable of y, which I always do. So solve for y and substitute that answer into your next answer. Okay, so for this first one, we're going to make y equal to negative 3x, because we're bringing it to the other side, minus 9. And then what we're going to do is we're going to take this answer of y and we're going to plug it into this spot right here of the second equation for y. Our goal is to get rid of two variables and only solve for one variable. So we only want one variable in this, so this is the method of substitution. So we're plugging in negative 3x minus 9 in the spot of y. So 4x squared minus x stays the same, but then we're going to have plus in brackets negative 3x minus 9 equals negative 9. Everything else stays the same except for what I substituted, which was this. Then addition doesn't change anything, so we're just going to rewrite it as negative 3x minus 9 once we distribute that positive that was in front of it. And then it's all about just this is all about just trying to simplify this as much as possible. So for example, I'm going to add 9 to both sides to get 0 on one of the sides. So that actually crosses off and simplifies a lot of this stuff. And then you have 4x squared left, and then negative x minus 3x is negative 4x. So this is as simple as you can go. But what we're going to do is we're going to factor to solve now. So factoring means you can take out the common 4 and the x from both those terms, leaving us with x minus 1 equals 0. So that means that 4x could equal 0 because you take each factor, and x minus 1 could also equal to 0. So that means that x is equal to 0 and x equals positive 1 could equal 0. So we always need to plug this back in to see if left side equals right side. So we're going to take our answers, and I'm going to only show you this the first time, but if they ever say check, you should always check your answer. So these both are solutions, but to really confirm that, we want to say, well, let's make x equal to 0 and solve for y. We need the y coordinate as well. So it's not enough to just say, there's my x values. You need to solve for y. So we want to go 3 times 0 for x. This is the first equation that we have, the linear one, plus y equals negative 9. Well, what is y? This is 0, so y equals negative 9. So our coordinates, our solution has to be the x coordinate and the y coordinate that would work for the equation. So that's one answer. Now we need to do this again for 3 times 1 plus y. What's equal to negative 9? Well, 3 plus y equals negative 9, and subtract 3 on both sides, which gives us that y equals negative 12. So our next coordinate would be 1 and negative 12 as our second answer. So those are the two solutions you need to include. They are coordinates. They have to be the points where these two equations are intersecting. So if you stop right here, that's only half the work. You still need to figure out the other coordinate where it's going to intersect at. So you need to solve for the y answer. Okay. So a checking mechanism right now would be to plug in those points into the second equation to see if left side equals right side. But I know that they're both answers, so I'm going to move on. The next thing you need to be able to do is write the equation that represents the scenario. So for example, they're saying 14 more, so 14 plus twice the first integer, we're going to call x the first integer, gives you the second integer. So y will be the second integer. And each sentence represents a new equation. So the next sentence, we're going to say the second integer, which is y, we know is y, increased by 1, is the square of the first integer, meaning x squared. So those are my two equations. So in this case, again, because we have a quadratic and a linear equation, we're going to do substitution. So we're going to sub in one equation into the other by solving for y. Y equals x squared minus 1. So solving algebraically, we're going to put this equation into the y spot right there. So 14 plus 2x equals, instead of y, x squared minus 1. So we're going to bring everything to one side. So we're going to have 0 on the left side, and we're going to have x squared minus 2x because we brought it over. Then it'll be minus 1 minus 14. So that gives us x squared minus 2x minus 15. So there's our equation that we can actually factor to solve. Two factors that multiply to negative 15 and add up to negative 2 would be x minus 5 and x plus 3. So that means that the solution for x could equal 5 or negative 3 if we solve for it. So this is from factoring quadratics. Once you find your x coordinate, you need to solve for the y coordinate by substituting it back in. So we know that y equals x squared minus 1 from this, right? So let's sub in the first value. Well, y is equal to 5 squared minus 1. So that would be equal to 24. So one answer will be 5 and 24. Then we do that again with negative 3 in brackets squared minus 1 will give us 9 minus 1. So we know that the second set of coordinates is negative 3 and 8. So those are our two solutions again. So we have two intersection points between these two equations here.